that sound? That is not a soundtrack. That is real data. The radio cry of a dead star turned into sound. A corpse 20 kilometers wide, screaming across the galaxy. On December 27th, 2004, at 9:30 p.m. Universal Time, that scream reached Earth. In 0.2 of a second, it dumped more energy into our sky than the sun releases in 250,000 years. Satellites went blind. Instruments built to study the most violent events in the universe were saturated in an instant. The upper atmosphere of our planet flinched. The source was not a black hole. It was not a supernova. It was something smaller than a city, and it was 50,000 light years away. To understand what touched us that night, you have to watch a giant die. A star, 20 times the mass of our sun, runs out of fuel. Gravity wins. In a fraction of a second, the core collapses and the rest of the star detonates. What is left behind is not really matter as you know it. It is a single, city-sized atomic nucleus. A neutron star. 1 teaspoon of it weighs as much as a mountain range. It spins hundreds of times per second. It is 1 billion degrees of Earth. And in roughly 1 star out of 10, something goes wrong. The collapse twists the star's magnetic field into a monster. We call him Magnetar. The strongest magnets human beings have ever built reach about 100 Tesla for 1,000th of a second before they tear themselves apart. A Magnetar's field is 100 billion Tesla, permanently. From 1,000 kilometers away, that field would not kill you with heat or with radiation. It would dissolve you. It would stretch every atom in your body into a needle. Chemistry itself stops working. Fly past one from halfway to the moon, and it would erase every credit card on Earth. This is not a place where physics gets strange. This is a place where matter gives up. We know of about 30 of them in our galaxy. 30 confirmed monsters among hundreds of billions of stars. Most of the time, they are silent. That silence is a lie. On October 10th, 2020, a magnetar called SGR 1830 woke up. 13,000 light years away, in the constellation Scutum, its solid crystalline crust, a shell 1 kilometer thick, finally gave way. Imagine the ground beneath you, stressed by a magnetic field 100 billion times stronger than Earth's, bending year after year until it snaps. A starquake. If our strongest earthquakes are a magnitude 9, a starquake is a magnitude 32. The crust shatters like glass, and the wound glows in X-rays. NASA's telescopes watched 3 hot spots drift across that surface for months. Continents of fire on a dead star. And here is the uncomfortable part. SGR 1830 was only discovered because it screamed. Of the 30 magnetars we know, almost all were found the same way. We did not find them. They announced themselves. Which brings us back to December 2004. The scream that opened this story came from SGR 1806 to 20, a magnetar on the far side of the galaxy. What happened that night was not a starquake. It was the crust and the field failing together all at once. Astronomers call it a giant flare. In 0.2 of a second, SGR 1806 to 20 outshone every X-ray source in the sky. Combined, the gamma rays crossed 50,000 light years of empty space and still ionized Earth's upper atmosphere like a small solar flare. It bounced off the moon, Detectors pointed away from the source saw the echo reflected back at us from lunar rock. One event lighting up both sides of our sky. Here is the question nobody likes to ask. SGR 1806 to 20 is 50,000 light years away, and we felt it. Was the safe distance? The honest answer, a giant flare within a few light years would strip our ozone layer. There is no magnetar that close, that we know of. Remember, most magnetars are invisible until they erupt. The map of the galaxy's most violent objects is a map of the ones that have already fired at us. For decades, that was the whole story. Then, in 2007, astronomers found something new in old data. A radio burst lasting a few milliseconds, carrying the energy signature of a source billions of light years away. Not thousands, billions. They called them fast radio bursts. Hundreds of theories try to explain them. Aliens made the list. And then, on April 28th, 2020, the universe handed us the answer. A magnetar in our own galaxy, SGR 1935, fired a radio burst straight at us. For the first time, a fast radio burst had a confirmed source, not a theory, a monster we already knew by name. Think about what that means. Every fast radio burst arriving from across the cosmos may be a magnetar's giant flare, the same event that touched Earth in 2004, happening in another galaxy, reaching us across billions of light years. Observatories like CHIME in Canada now catch multiple fast radio bursts every single day. Each one a potential scream from a dying magnetic field somewhere on the other side of the universe. The sky is not quiet. It never was. We just learned how to listen. SGR 1830 has gone quiet again. Its outburst faded back into the noise of the galaxy. But it is still there, still spinning, still loading stress into a crust that will, one day, fail again. The next time it speaks, we will be listening. The next time a giant flare erupts in our galaxy, we may have milliseconds of warning, or none at all. 50,000 light years is not far, not cosmically, close enough to matter, close enough that one night in December, a dead star reached across half the galaxy and touched you. Without a telescope, you would never have known. That sound you heard at the start? The galaxy makes it all the time. Sleep well.